All right, the purpose of this lesson is going to be evaluating trig functions for the domain when the angles are measured in degrees. All right, we can measure angles and other things than degrees. Degrees is the only angle measurements we've worked with so far. Previously, we only knew how to find the sine, cosine, and tangent of an angle, and specifically an acute angle. We've since then extended it to angles greater than 90 degrees, as well as greater than 360 degrees. We've also extended it to below 0 degrees. So now we can have basically any real number as an input, but measured in degrees. All right, so if we go back to when we first learned about trig functions, sine is the opposite of hypotenuse, so we can think about SOHCAHTOA, so S-O-H, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. The other three trig functions are the reciprocal of that, so you would just take the sine, reciprocal is cosecant, take cosine, reciprocal secant, take tangent, reciprocal is cotangent. So we're going to look at how we can set up each of these trig ratios so that we can find it for 0 degrees, 30 degrees, 60 degrees, 45 degrees, 90 degrees, and anything that is coterminal with those angles. So if I was looking at the diagram to the left, which could be a triangle inside the unit circle because we have the hypotenuse is 1. So the sine of theta for this triangle would be y over 1, or just y. That's what we talked about in the unit circle, so sine of theta is y. Similarly, cosine adjacent over hypotenuse would be x over 1. Cosine is equal to x. Now we haven't talked about tangent, cosecant, secant, or cotangent in terms of this. So if I use tangent, well, that would be y over x in the diagram. Cosecant would be the reciprocal of sine. So one way you can always write the reciprocal is 1 over. All right, reciprocals are the same thing as a multiplicative inverse. If you multiply the two things, you get 1. So y times 1 over y is 1. Similarly, secant would be 1 over x. Cotangent could be 1 over tangent, but since tangent is written in terms of y and x, well, we can make that x over y. Now, this isn't particularly helpful because you'd have to know what x and y are, but since x and y are sine and cosine, well, I can replace anything that's y with sine and anything that's x with cosine, right? And I don't even need to think of sine and cosine being x and y unless I'm thinking in terms of the unit circle. So tangent would be then defined as sine over cosine, which would mean cotangent is cosine over sine. Cosecant would be 1 over sine, and secant would be 1 over cosine. All right, and this is, we've found these values as well before, but now we're just going to organize it. So we did this probably about 2 tutorials ago, but we're going to organize it. So if we look in this table, all right, so this is going off unit circle values. Well, the sine of 0 degree sine is the y, so as I'm going up, it starts at 0, goes up to a half, then root 2 over 2, then root 3 over 2, and at the very top, the length is 1. All right, the x values start all the way to the right at 1, and then they start coming inwards. So this is really like going from greatest to least, whereas the other one's least to greatest. All right, you'll notice the pattern in the table where as sine runs to the right, the same numbers run to the left for cosine. All right, to calculate the tangent of all of these, well, we defined on the previous slide that tangent is sine over cosine, which in the table it's already set up as sine over cosine, so I'd have 0 divided by 1, which is just 0. And then I have 1/2 divided by root 3 over 2. Well, if I'm dividing by root 3 over 2, it's the same thing as multiplying by the reciprocal, so that's 2 over root 3. The 2's would cancel out. I'd have 1 over root 3. And usually we rationalize the denominator, so I'd multiply by root 3 over root 3. And this comes out to root 3 over 3. Now is an important time to look at, well, we know that cotangent's the reciprocal of that. So cotangent is cosine over sine. So for cotangent, you would also have to do 1/2 divided by root 3 over 2, except for you would be doing that with 60 degrees. So this would be root 3 over 3 down here. Right. Similarly, when we do 0 over 1, that would be for 90 degrees. Right. So that pattern of as it's going to the right, the reciprocal is running to the left. So this is going to speed up the process as far as finding the value of each of these trig ratios. All right, next one, root 2 over 2 divide. Well, that's messy, but it's the exact same number, so something divided by itself would be 1. All right, then we'd have root 3 over 2 divided by 1/2, which would be times 2 over 1. Those cancel out, it's just root 3. All right, and again, I can fill in that table. And then we'd have 1 divided by 0, cannot divide by 0, this is undefined. All right, then we have cosecant and secant, so cosecant is 1 over sine, and secant is 1 over cosine. All right, so if I look at sine, I have 1 over 0, which is undefined. And then I'd have 1 divided by 1/2, which would be 1 times 2 over 1, so that's just 2. Then I'd have 1 divided by root 2 over 2, so 1 times 2 over root 2. And I'd have to rationalize that. So I'd get 2 root 2 over 2. All right, and I can go ahead and cancel those 2's out. So this is just root 2. Then I'd have 1 times 3 over root 2, because I'm dividing by root 3 over 2. Excuse me. All right, 1 divided by root 3 over 2, so it'd be 1 times 2 over root 3. Except for when I rationalize this one, it will not cancel out. I'm just going to be left with this ugly 2 root 3 over 3. And then I would have 1 over 1, which is just 1. And then it would run in reverse, which I forgot to put undefined down here. It would run in reverse, so this would be undefined. This would be 2 root 2, 2 root 3 over 3, and 1. All right, so these are all the values, or the absolute values, because we know that depending on where what quadrant the angle's in, it could be positive or negative. So the other important thing besides the absolute values, which is what's in this chart, is known quadrants. All right, now we've talked about for cosine and sine. Well, cosine is x, sine is y, so it's basically the same as when you first learn the quadrants. That'd be positive. This is x, so negative, negative, positive. All right, so for sine, positive, right, because it's y values, negative, negative. All right, secant is the reciprocal of cosine, which just flipping the numbers, it doesn't change the sign. So anywhere that cosine's positive, secant's positive. Anywhere cosine's negative, secant's negative. The same is true for cosecant's relationship with sine. All right, tangent is sine divided by cosine, so a positive divided by a positive is positive. A negative divided by a negative, excuse me, positive divided by a negative is negative. A negative divided by a negative is positive. And a negative divided by a positive is negative. And then cotangent would be the same in each quadrant. All right. A quick mnemonic would be, all right, so we can split that out. So now we can see all the values as well as the signs in each quadrant. So for negative 60 degrees, first I'd want to find the angle that's between 0 and 360. So I can basically add and subtract full rotation. So I'm going to be adding 360 or subtracting 360. So if I add 360 to this, that'd be the sine of 300 degrees. All right, so 300 degrees is the angle that's coterminal with negative 60, but between 0 and 360. 300 degrees would have a reference angle of 60 degrees because it would be an angle measurement. The angle from the coterminal side to the x-axis would be 60 degrees. So it's the same thing as sine 60, except for it's lying in quadrant 4. All right, and sine in quadrant 4 is negative, so I can look on the chart and go, okay, sine of 60, that's root 3 over 2, but it's quadrant 4, so this would evaluate to negative root 3 over 2. All right, cosine of 1200 degrees, so I'd be subtracting 360. So 360, 720, 1080. So 1080 would be the largest thing I could subtract without becoming negative. So if I subtract 1080, I would get the cosine of 120 degrees. All right, 120 degrees has a reference angle of 60 because that's the angle it forms with the coterminal side and the x-axis. So that's the same thing as cosine 60, but it's in quadrant 2. All right, cosine's negative in quadrant 2, and the cosine of 60 degrees is 1/2, so this would be negative 1/2. All right, so I'm using coterminal angles to get between 0 and 360. I'm using reference angles so I know what to look up in the chart, and then I'm also identifying the quadrant of that angle, so the quadrant of the coterminal angle, so I can determine if it's positive or negative. So tangent of negative 660, so 360 wouldn't be enough, but 720 would be, so it's the same thing as tangent of 60 degrees. Okay, I don't need a reference angle. I know it's in the first quadrant. I know it's positive. I can go just right in the chart on this one. So tangent of 60 degrees, that is the square root of 3. All right, cosecant of 300 degrees. Again, I don't have to find the coterminal angle, but the reference angle for 300 degrees is 60 degrees. So this would be the same thing as cosecant of 60 degrees, except for it's in quadrant 4, which cosecant is negative in quadrant 4. So I can look up my chart. Cosecant of 60 degrees is 2 root 3 over 3, but it's negative, so it'd be negative 2 root 3 over 3. All right, secant of 750 degrees, so I can take away 360 twice. It's the same thing as secant of 30, which I can just look up in the chart. So the secant of 30 degrees is 2 root 3 over 3. Right, cotangent negative 900, so I'd have to add 1080 because 720 wouldn't be enough. So that'd be the same thing as cotangent of 180 degrees. All right, and the cotangent of 180 degrees, well, that's the same thing as 0 degrees, right? If I look at the quadrant angles, 180s basically on the x-axis, just like 0 degrees is on the x-axis. Right, so I can think of it as, right, if I look at the coordinates, it's like it's at negative 1 comma 0. Well, tangent's usually sine over cosine, but cotangent would be cosine over sine, so this would be negative 1 over 0. This would be undefined. And again, I could have just looked on the table for cotangent of 0 degrees. It's just kind of awkward to look at it for a reference angle, so I wanted to think of this as cosine and sine just to be sure. And so that one's undefined. So basically, it's a 3-step process of finding the coterminal angle, so it's between 0 and 360. If it's not in the first quadrant, then find the reference angle and state the quadrant so you can remind yourself if it's positive or negative. Then you can look at the values in that table and see, you know, the absolute value and it's positive or negative based on that quadrant. All right, so hopefully this is helpful in evaluating trig functions. There'll be more tutorials in terms of evaluating trig functions with radians as well.